Good morning, students. Uh, Today we will study about the polynomial of class 10. So directly before going on the topic, I will give some advice to you. First thing is that take a notebook with pen so that the important things, whatever I am teaching now, you can note it down. And the second thing, after this session, I will give some assignment which will be uploaded on the ERP. So go through the ERP and whatever assignment I am giving you, you try to solve it after the session. So now we will start our topic polynomial. So in a polynomial, here objective I have written in this chapter, and today's session we will study about the introduction of the polynomial, type of the polynomial, degree of the polynomial, value of the polynomials, zeros of the polynomial, and geometric meaning of the zeros of a polynomial. So this all the content I will cover in this topic. So first is the introduction part. So in the introduction part, this polynomial is not new for us because this topic already we have studied in class 9. So I hope so you all are aware about the polynomial. So polynomial is an algebraic expression which is used a single variable, like it is represented by the px, qy and fz. So here the polynomial px shows that the polynomial in terms of x, and this is the another polynomial which is in terms of y, and here the next polynomial which is in terms of z. Some example I am writing. If I have written x plus 2, so this is the polynomial in terms of x. Here let's suppose y square plus y plus 3. So this is the polynomial in terms of y. Similarly, let's suppose z power 5 plus 5. So this is the polynomial in terms of z. So this is basically the introduction part of the polynomial. And the most important things in a polynomial, you have to note it down. The degree or the power of the polynomial should not be negative. It should not be negative, and the power should not be in the fraction. This power should not be negative and not in the form of fraction or rational. This part I will ask. Now we will see the type of the polynomial. In a type of polynomial, first we will see non-zero constant polynomial. Second, constant polynomial, zero polynomial, linear polynomial, quadratic polynomial, cubic polynomial, then biquadratic. Biquadratic polynomial. So in a non-zero constant polynomial, it is represented by fx, fy, fz is equals to k or any constant value 2, 3, 4, 5. Let's suppose you have written 5x plus fx is equals to 5, fx equals to 9. So this is the non-zero constant polynomial. And next is the zero polynomial. It means that if I have written fx equals to 0. Okay, so this is the zero polynomial. Then linear polynomial. Here fx equals to, let's suppose x plus 2. And then the quadratic, let's suppose fx is equals to x square plus 2x plus 3. Now I will tell you later why I am saying it linear, why I am saying it quadratic, why I am saying it zero polynomial, and what is the specific character or characteristic it has. Then the cubic, x cube plus 3x square plus 5x plus 3, and then the biquadratic, it means that the now these all are the types: non-zero constant polynomial, zero polynomial, linear polynomial, quadratic, cubic, and then the biquadratic. So these all are depend on the degree of the polynomial. Why we have categorized? So these all are categorized on the basis of their degrees. So how and what is the degree of the polynomial? Now we will see. So in a degree of the polynomial, it means that the highest power of the polynomial is known as the degree of the polynomial. Highest power, it means that, see, in a non-zero constant polynomial, that means fx equals to k, fx equals to 5, let's suppose. So in that condition, variable x is not used in the polynomial. So in that, the degree of this polynomial is 0. In which degree of this polynomial I am writing here. So in a non-zero constant polynomial, the degree is 0. But what will be happen in a zero polynomial? What will be the degree of this polynomial? This is the most important things. Many times this question can ask in your MCQ type question. The degree of the zero polynomial is not defined. This is the most important thing. The degree of the non-zero polynomial is not defined. After that, linear polynomial. The linear, as we have studied in class 9, the degree of this polynomial is 1. And in a quadratic, the degree of the quadratic polynomial is 2. And in a cubic, the degree of this polynomial is 3. And biquadratic, the degree of this polynomial is 4. Now, what will be happen if the degree of the polynomial is more than 4? What is called? Because polynomial, the degree of the polynomial we can write 100, 1000, 1 lakh. So what is called? So whenever the degree or power of the polynomial is more than 4, it is known as the polynomial. Now, I am writing some example and you will justify if these are in the form of a polynomial or not. See. Some example: x plus 1 upon x. Example 2, 1 upon x square plus 2x plus 3. Next, 1 upon x plus 1, and fourth, x to power 2 by 3 plus x plus 5, and one more, root of 5 root x plus 3. Now you see and find out these all are in the form of polynomial or not. So see, in a first example, very first example, see, x plus 1 upon x. Is this in the form of polynomial? Yes or no? So this is not in the form of polynomial. Why? Just I have given one example, x plus 1 upon x. So this we can write x plus x to power minus 1. So now the power of this x becomes negative. And earlier what I have explained, the degree or power of the polynomial should not be negative and not in fraction. So this is not in the form of polynomial. Second thing also, 1 upon x square plus 2x plus 3. Is this in the form of polynomial? This is also not in the form of polynomial because this all the things is given in denominator. Then what will happen about example number 3? So this all the 3, question number 3, 4 and 5 you will solve and you will tell me these are in the form of polynomial or not. Let me explain example number 5. Here 5 root x plus 3 is given. So is this in the form of polynomial? This is also not in the form of polynomial, because this we can write 5 x to power 1 upon 2. Root of x, it means that we can write x to power 1 upon 2. Now the power degree becomes in fraction. So this is also not in the form of fraction. After that we will come on the next topic, value of the polynomial. Now value of the polynomial, it means that if a polynomial we are having anything, let's suppose 2x plus 5, and if we are replacing value of x is, let's suppose x equals to 1, and if you are substituting x equals to 1 in this polynomial, so what will be happen? So in a p1 will be equals to 2 into 1 plus 5. So 2 into 1 2 plus 5 7. So this shows the value of the polynomial 7 at x equals to 1. Similarly, if you are taking x equals to 2, so what will be happen? P2 is equals to 2 into 2 plus 5. So 2 2s are 4 plus 5 is equals to 9. So 9 is the value of the polynomial at x equals to 2. So here the value of polynomial we can find at any point. If point is given, so it is okay. Otherwise we can find out the value of the polynomial at many points. As you can take x equals to -1, -2, 0, 3, 4, 5, anything. So this is called the value of the polynomial. Now we will come on the next topic, zeros of the polynomial, and this is the most important, zeros of the polynomial. In a zeros of the polynomial, what will be happen? Just we have seen the value of the polynomial. Now we will see about the zeros of the polynomial. So in a zeros of the polynomial is that if we are taking the value of x, anything, and after solving if you are getting 0. If you are taking the value of x, anything, and after substituting the value in the polynomial, if you are getting 0, so this particular value of x is known as the zeros of the polynomial. Now you just see one example I am writing, fx equals to x plus 5. Very simple example I am taking. Here fx equals to x plus 5. Now let me explain. If x equals to -5, if I am taking, what will be happen? Substitute this value. So if -5 we are substituting in a polynomial, so f minus 5 is equals to -5 plus 5. -5 plus 5, what will happen? You will get 0. So here x equals to -5 shows the zeros of the polynomial fx equals to x plus 5. So I hope it will be clear what is the zeros of the polynomial. Zeros of the polynomial, again I am explaining, when we substitute a particular value of x and after solving the polynomial if you are getting 0. So this particular value is known as the zeros of the polynomial. Now one more example. Let one more example of quadratic polynomial. If I have written x square plus 5x plus 6. X square plus 5x plus 6. Now what will be the zeros of this polynomial? Now let me check. If you are substituting x equals to 1, what will be happen? So here f1 is equals to 1 square plus 5 into 1 plus 6. So 1 plus 5 plus 6. 5 plus 6, 11 plus 1, 12. We are not getting is equals to 0. So we can say that x equals to 1 is not the zeros of this quadratic polynomial. And if you are taking x equals to -2, what will be happen? Substitute the value and check it. So f -2 is equals to -2 whole square plus 5 into -2 plus 6. So -2 whole square 4, 5 into -2 -10, and then plus 6. Now these both are positive and this one is negative. So 4 plus 6, 10, and 10 minus 10, what? 0. So x equals to minus 2 when we are taking in this polynomial. So what we got? 0. So this shows the zeros of the polynomial. So x equals to minus 2 will be the zeros of this quadratic polynomial. Fx equals to x square plus 5x plus 6. Now we will come on the last topic, geometric meaning of zeros of a polynomial. This is also most important. One question 100% comes from this topic in your final exam. Geometric meaning of the zeros of a polynomial. So what is the geometric meaning? What do you understand by the geometry? The geometry, it means that when this numerical content we are representing on the graph, how to demonstrate this numerical value to the graph. So this known as the geometric meaning. So how we can define the zeros in a geometric form? So everyone knowing and everyone has seen the graph. It's look like this, and this is the origin part 0, and from if I am moving from the right side positive, and if I am moving toward the left side it is negative. So 1, 2, 3, 4, minus 1, minus 2, minus 3. Similarly upward side positive and the downward side negative. So now we will see the geometric meaning of the zeros. So in this topic, if as we have seen that in a linear polynomial, what will be happen? What is the graph of the linear polynomial? Is a straight line, as we have studied in class 9th also. So in a linear polynomial, let's suppose this is a straight line. Let's suppose this is the line of any linear polynomial. So whenever this line intersects the x-axis at any point, whenever any straight line, any curve intersecting the x-axis at any point, so this intersecting point is known as the zeros of the polynomial. Let's suppose one example, if fx is equals to x plus 2 if I am taking. So x equals to minus 2 will be the zeros. You can substitute and you can check. So x equals to minus 2 gives minus 2 plus 2 is equals to 0. So similarly, if you take 2 solution of this polynomial and if you draw the line, so this line will get this type, and this line intersect the x-axis at which point? Minus 2. So this minus 2 shows that the zeros of the polynomial. Similarly, if we are talking about the quadratic, cubic, biquadratic, so what will be happen? Just I am showing you and you will see in your assignment. I have given you some question related to that topic. This you will see in your assignment. Let's suppose if a graph we are having, and if let's suppose this graph intersecting the x-axis at this point 0, and let's suppose at point this 5. So what will be the zeros in this graph? So this curve intersecting the x-axis at exactly 0, and this is also intersecting at 5. So x equals to 0 and x equals to 5 will be the zeros of this polynomial. So today what we have covered in this session, we have covered the introduction part as we have studied in class 9, and the type of polynomial we have just seen: non-zero constant polynomial, zero polynomial, linear polynomial, quadratic, cubic and biquadratic. Then we have studied about the degree of the polynomial. The highest power of the polynomial is known as the degree of the polynomial. Then the value of the polynomial, It means that if any value of x we are substituting in a polynomial and whatever we are getting, this shows that the value of the polynomial, zeros of the polynomial, and this last topic just we have studied the geometric meaning of the zeros of the polynomial. Thank you class.